Okay. So, now average and RMS values of a sinusoidal voltage or a current, right. So, let us first go through the average value. So, in this is I, this is V also, right. I forgot to put it here, it is V also, because this thick line, this continuous line, it is basically it is that current plot. So, it is something like this, and say this dash line, it is the voltage, and the peak value for this one is your Im, it is Im, and peak value for this voltage is Vm, right. So, this is the peak value of the voltage. So, this is Vm and this is your Im, here it is marked, and it is a Vm. So, this is continuous line is current and your dash line is the voltage, right, and this is a sinusoidal waveform, purely sinusoidal waveform, and theta is equal to omega t, right. So, I is equal to expression is Im sin theta, right, because and this is 0, and we will make the average value over a half cycle. So, this can be written as your I average is equal to your 1 to pi, because divide this by pi, and 0 to pi I d theta, right. So, it is because we will make only for this portion over a half cycle. So, limit should be 0 to pi, right, and divided by the base, that is pi, that is 1 upon pi I d theta, right. So, in this case this side will come to that, this side is for your what we call for RMS value. So, it is basically I is equal to Im sin theta. So, 1 upon pi 0 to pi capital Im sin theta d theta. So, if you integrate it, it will be 1 upon pi Im minus cos theta 0 to pi, right. So, let me clear it. So, in this case it is coming, basically it comes 2 upon pi after simplification into Im is equal to 0.637 Im, right. So, this is your what you call that your average value, that means my I average, this same thing, I average is this much, 2 upon pi Im is equal to 0.637 Im. Similarly, you will get V average also, because same way just I am writing one line, same way you can make say V average, right. Say V average is equal to 1 upon pi 0 to pi, right, your Vm sin theta d theta, same thing, right, same way you integrate, and similarly you will get V average is equal to same 0.637 into Vm, same we will get, because both are sinusoidal waveform only, right. So, Va average will be 0.637 into Vm, right. Vm is the peak value of the voltage, similarly Im is the peak value of the current or maximum value of the current, and here it is maximum value of the voltage. This is your average value. Now, let me clear it. Now, when you come to your RMS value, this is suppose only in this case I square plot is given, right. This is Im and this is your I square, right. I is equal to Im your sin theta. So, I square will be Im square sin square theta, right. So, this is your I square plot, this side is I square, it is marked here, this is I square, right, and this peak is your what you call Im square, and if you plot it, it will be like this. This area and this area, it is same, it is symmetrical, and this is pi, this is 2 pi, this side is theta, right. So, that means I square is equal to Im square sin square theta. So, let me clear it. So, here I RMS is equal to, it is because we have seen no, this under root square you have to take. So, it is 1 upon pi 0 to pi I square d theta to the power half, because it is square root. So, to the power half, right. So, it is your whole thing to the power half, 1 upon pi 0 to pi I square d theta. Here is 1 upon pi 0 to pi I d theta for average value. For RMS value 1 upon pi 0 to pi, instead of I it will be I square d theta to the power half, right, square root. Now, this will be your 1 upon pi, then your 0 to pi I is equal to Im square sin square theta, right. So, it is I is equal to Im sin theta. So, I square is equal to Im square sin square d theta, right, is equal to your 1 upon pi bracket 1 upon pi 0 to pi Im square by 2 1 minus cos 2 z d theta, because cos 2 theta is equal to 1 minus your 2 sin square theta. Therefore, sin square theta is equal to 1 minus cos theta by 2. So, that is it made it here, and you integrate and to the power half, everywhere to the power half, square root. If you integrate and simplify, it will simply become Im by root 2, that is 0.707 Im, right. So that is your IRMS, we call root mean square value, IRMS is equal to Im by root 2, right. So let me clear it. Similarly for the voltage, Vrms also 0.707 Vm. The way I told you V average this thing, here also instead of just your Im square sin square theta, you make it Vm square sin square theta d theta, V is equal to Vm sin theta, right. So in that case Vrms also will be your 0.707 Vm, right. So therefore let me clear it. Therefore the average value of a sinusoidal current or voltage will be 0.637 into maximum value, right. Average value of a sinusoidal current or voltage both are multiplied by 0.637, right. Similarly, the RMS value of a sinusoidal current and voltage both are multiplied by 0.707 into maximum value. This is the maximum value, this is the maximum value, right. Now we define one or two things. Form factor of a sine wave, right. Form factor of a sine wave, RMS value by average value, right. So RMS value is equal to this RMS value is equal to 0.707 into maximum value, and average value is equal to 0.637 into maximum value, that equal to 1.11. So for sinusoidal waveform the form factor is 1.11, right. So you have to keep it in your mind, right. So the sinusoidal waveform. Now let me clear it. Similarly, the peak or crest factor, right, this one it is crest factor, right, of a sine wave, maximum value by RMS value. So maximum value and RMS, the maximum value, keep it as maximum value, and RMS value is equal to 0.707 into maximum value, that is actually 1.414, right. This is called peak factor. That means later we will see that any AC voltage, suppose if it is told 220 volt, that is basically RMS value, unless and until it is not mentioned, and if it say 220 volt AC, you have to assume this is RMS value. That means this peak value will be multiplied by this factor, this is actually root 2, you have to multiply by this factor, right. So that is the idea, that in AC anything we calculation, anything we do, that is on RMS value, but if it is as the peak value, it will be multiplied by this your what you call root 2, right. So that is your what you call peak factor. So let me clear it. Therefore the RMS value is always greater than, this RMS value is always greater than average value for a your average value, except for a rectangular wave, particularly for your square wave, because different waveform you can generate, right, in which case the heating effect remains constant, so that the average and the RMS values are the same, right. So RMS value is always greater than average except for a rectangular waveform, right, particularly square wave. So anyway, so that means that details a little bit we will see on this, right, that how it is. Now symmetrical and unsymmetrical. So form factor, crest factor, average value, RMS value, I think it is understandable to you, right. Anything is mentioned in the numerical, unless and until it is specified, it is RMS value only. If it is mentioned maximum value or peak value, you have to divide it by root 2 to get that your RMS value, right. So now next is that symmetrical and unsymmetrical waveforms. So the waveforms in which plus and minus half cycles are identical are referred to as the symmetrical waveform. But like this is sinusoidal one, is plus and minus, right, your half cycles are identical, so it is a symmetrical waveform. This is a triangular waveform, this is a triangular waveform, and it is symmetrical because this side and this side is same. Look, this is 0, this is your what we call t by 4, t by 2 t, so it is pi by 2, say if it is a pi by 2, it is pi, so it is 3 pi by 4 and it is 2 pi, right. So this way this side is symmetrical and this is also symmetrical, so this is symmetrical waveform, it is triangular. Similarly this is square waveform, so this one is symmetrical. If it is 0, if it is t by 2, it is t, it is symmetrical, and this is your theta, it is theta, right. So this is these three waveforms are symmetrical waveform, that means that plus and minus half cycles are identical, are referred to as the symmetrical waveform, right. Identical means this side positive area, negative area, both will be same, right. So and let me clear it. Similarly, you may have other type of waveform. Suppose if it goes like this, if it goes like this, if it goes like this, it goes like this, right, some exponential thing, this is also symmetrical, right. So anyway, that's why one dash line is shown here, right? And another thing is that for this one, suppose I want to find out, we do 0 to half cycle. If you draw this line, this side and this side, it is same, identical, right? If you draw this this thing, this side and this side is same, it is symmetrical. So instead of half cycle average value, you can make it quarter cycle also, 0 to t by 4. It will give you the same result, right? It will give you the same result. Similarly, here also it is a triangular waveform. If you try to find out what is the average value of this triangular waveform, it is a say symmetrical waveform in between 0 to pi, right? Whatever result you will get, that right. So same you will get in between 0 to pi or 0 to t by 2. Here also 0 to your what you call this is 0 to pi by 2 or 0 to 2 by 4. This side will give, because this side area and this side area it is same. Even that means in quarter cycle, whatever RMS or average value you will get, you take half cycle also, you will get the same value, because this side and this side, left hand side and right hand side is same. This is and this is, this one and this one, this side area and this side area, it is same, symmetrical. You will get the same result, right? So some problems from your intuition you can do it, things you can do it in very simple way rather than completing the half cycle. If you see that things are totally, or what you call that is symmetrical, right? So let me clear it. Similarly, that unsymmetrical waveform, if you look into this, this is your I say this is 0, this is same as before, say this is pi, this is 2 pi, like this, right? So waveform is there up to this, after that nothing is there, then it is like this. So this portion, dash portion, nothing is there here, right? But complete cycle is 0 to 2 pi, right? But it is going your up to 0 to pi, after that nothing is there, is 0, but your total, your complete cycle is 2 pi. So it is unsymmetrical waveform. You have to consider that your what you call the total, your there you are taking that base is half cycle, here you have to take base for complete cycle, right? So that means although it is 0, say it is 0, it is pi, it is 2 pi. So you have to find out this area to get this average value or RMS value, but you have to divide it by 2 pi, you have to divide this by 2 pi, but you will integrate from 0 to pi, because this dash line is shown that if it is there, but it is not there, it is not there. So it is going like this. So for asymmetrical waveform, right, when it is not symmetrical, you have to consider the complete cycle, total base divided by whatever integration will be 0 to pi. We will see some example. Similarly, here it is also, here also it is like this, it is unsymmetrical. It is unsymmetrical waveform, this side then this side is not matching, this side and this side is not matching, and this is your 0 and this is your t, right? Again, because this waveform is starting here, again this waveform is starting here, this is t, right? So it is your what you call this one, it is your t by 4, this point is t by 2, this is 3t by 4 and this is t, right? So this is unsymmetrical waveform. So in that case you have to, but when you try to find out that your average or RMS value, you have to consider the complete cycle, that is your complete your what you call that complete base from 0 to t, that division should be t, right? For unsymmetrical waveform you have to consider the whole cycle for getting average value or your RMS value, right? So this is the idea for this one, your what you call symmetrical and your what you call as unsymmetrical waveform. For unsymmetrical waveform, you have to consider that complete cycle to get that your average value or your RMS value, right? For symmetrical waveform, you have to consider half cycle or even quarter cycle. Looking at this, it will give you the same result. But for unsymmetrical waveform, you have to consider your what you call that your complete cycle, right, to get that average value or RMS value, right? So hope this is understandable to you. So next is that suppose in the case of unsymmetrical waveform, your what you call the average value must always be taken over the whole cycle. I told you that average value, your what you call, must be taken over the whole cycle. So I average should be 1 upon t, 0 to I dt. Similarly for voltage, V average you have to consider for the whole cycle. So 1 upon t, 0 to dt, V dt, right? And in case of symmetrical alternating current or voltage, right, the average value over a complete cycle is 0. So the average value is taken over the half cycle, because if it is symmetrical, that I told you the positive area and negative area will be same. So in that case your what you call the average value will be 0, that's why we will consider that half cycle for average value, right? Now second thing is to determine the RMS value of an alternating quantity, it is immaterial to take the average over half cycle or complete cycle. I told you RMS value means a square, so I told you that as soon as squaring it, if you take half cycle or full cycle, it will give you the same result, right? Because area for half cycle and another half cycle remains same. If you take half cycle, whatever result you will get, take full cycles, you will get the same result, right? Now, just hold on. Now, therefore, for case A, B, C, we may even consider a shorter interval, right? That is your what you call the t by 4 as is symmetrical about this your point t by 4. For the triangular waveform, look, triangular waveform, how we will do it, right? Just try to understand this, because suppose we want to, suppose this is your what you call, this is 0, this is t by 4, this is t by 2, this is 3t by 4, and this is t, right? So, this total your what you call this base length is t, right? For this one, if you take, this is my Vm V, and this is your peak value, this height is your, this is my Vm, right? Then the slope of the straight line, will be Vm, this is height is Vm and base is t by 4, right? And this is the slope, and that equation is equal to this straight line is passing through the origin. That means your, you know, in general for straight line y is equal to mx, that you know, but y side is v. So, this is v should be equal to m into t, right? And your m is equal to nothing but this is your slope, v is equal to Vm upon t by 4. That means somewhere I am writing, I am writing somewhere here, right? Let me see, find out some space. So, here I am writing that v is equal to, right, m is equal to your Vm divided by t by 4, right, into the t. This is the straight line passing through the origin, because this time you take t, right. So, this is time, this way we will take, say t, instead of theta we will take t, right. So, v is equal to Vm t by 4 into t, right. So, let me clear it. So, that means if you come here, we will come to that again. That means if you come here, that V average value we are taking 1 upon t by 4, right, your what you call, then 0 to t by 4 Vm by t 4 into dt, right. So, this is your what you call that your V average that I told you 0 to t 4, and I told you this equation I told you that Vm by 4 t dt, right. So, if you simplify this, it will be Vm by 2, right. So, in your what you call, that is your V average. Now, that is your just hold on, because it is symmetrical waveform, just hold on. Sorry, this one, previously I talked about this one, sorry, this one actually t by 4, not this one, right. I overlooked this one, but this is your t by 4, and in that case for symmetrical waveform, because this side area and this side area is same. So, I told you this equation will be V is equal to Vm divided by t by 4 into t. This is also same thing for this one, will come later, right. So, it is t by 4. So, let me clear it. So, this is your average value. So, if you 0 to t by 4, if you integrate, it will become your what you call Vm upon 2, right. So, this will become Vn upon 2. Similarly, that V RMS value, it will be your 1 upon t by 4, 0 to t by 4. So, we got V is equal to Vm divided by t by 4 into t, and you square it. If you square it, it will be Vm square divided by t by 4 square into t square dt to the power half, right. And 0 to t by 4 you integrate, you will get Vm upon root 3, right. So, similarly, form factor you can find out, it will become 2 by root 3, 1.155, and peak factor will be 1.732. So, let me clear it. So, that means, I mean, here if you come again, that your form factor is equal to RMS value by average value, and your peak factor is equal to maximum value your what you call is equal to maximum value by RMS value. So, for this triangular waveform, then you will get your peak factor 2 by root 3, just simplify, you will get it 1.155, and peak factor root 3 by 1.732. And this one, now next one is, this is triangular waveform. Now thus from form factor of all waveforms, if you look into this, that this one is for your square waveform it will be 1, for sinusoidal waveform it will be 1.11, and for this triangular waveform you just do it, it will be 1.154. Just now we calculated, no? Just now we calculated for the triangular one. For the triangular one, we calculated 1.155. So here also it is actually it is 1.155, right? So this is for figure C, for figure A, and figure B, right? So for form factor for your square waveform it is 1, right? Now next, actually for unsymmetrical waveform, suppose this, for this case if you look into this, for unsymmetrical waveform you have to consider the whole base 2 pi, right? But this is your integration should be 0 to pi. So average value 1 upon 2 pi 0 to pi I am sin theta d theta will be 1 upon 2 pi I am minus cos theta d theta 0 to pi, right? So it is 1 upon 2 pi into, integrate it, you will get 1 upon pi into I m, right? Basically I m by pi. Now for RMS value it will be 1 upon 2 pi 0 to your pi I m square sin square d theta. Here your what you call 1 half is missed, so to the power half, right? So if you integrate it, then you will get I m upon 2 by root 2, right? So this is your RMS value. Now form factor will be same way you can get it, it will be 1.11, right? So although it is your half cycle other thing, but for it is waveform is sinusoidal, you are again getting 1.11, right? Now for this triangular waveform, your what you call, at that time I was showing this one, this triangular waveform, that this for finding out, suppose this is given, suppose this is unsymmetrical waveform, suppose peak is given 10 volt, right? And T by 4, T by, and this side it is minus 5 volt, this is plus 10 volt, right? So and that means the slope of the straight line will be this 10 divided by T by 4, right? So and another thing is that we have to come from 0 to t, right? From 0 to t we have to come. So in this case we have to consider the whole cycle. That's why you have taken v 1 upon t 0 to t v dt. This is a v average value. So first we have to consider this area, and then we have to consider this area. So for this is the equation passing through a straight line. So it will be your this equation for this straight line will be your v is equal to your this slope 10 divided by t by 4 into t, right? So for this part it is 1 upon t, then 0 to t by 4 10 divided by t by 4 into t dt. Now next one is, look, from your intuition you have to make it. Next one is that this portion. Now let me first clear it. Now this portion, if you try to find out a straight line of this equation, you have to make it y is equal to mx plus c. This way you have to make it, or other way you have to make it v is equal to your slope m into t plus c, right? So forget about this. So this way you have to get the equation. But remember, from the symmetry our interest is to get what is the area, right? How we will find out. So what you can do is, suppose if I bring this one, I mean just for the mathematical computation, nothing else. If I bring this one, suppose if it is here and if it is here, the area will remain same as if another straight line is passing to the origin, right? So in that case its slope will be minus 5 your what you call minus 5 divided by t by 4. Just we are just for mathematical thing, because if you want to find out y is equal to mx plus c, I mean v is equal to mt plus c, then you have to obtain m, you have to obtain c, right? Because this is one coordinate, this is another, you have to put and you have to solve for m and c. No need, just from the symmetry you bring this portion to here, as if it is passing, although in reality it is not, but as if it is passing through the origin, right? So in that case slope will be minus 5 into t by 4. Therefore this is also, and the integration will be also 0 to t by 4. This duration also 3 t by 4 minus t by 2 will be again t by 4, same thing, right? So this from here to here, this duration your 3 t by 4 minus t by 2 will be again t by 4, but that means same integration 0 to t by 4, we are taking this portion, that is minus 5 t by 4 into t dt, because this is straight line passing to the origin, this is a slope minus 5 t by 4 into t dt, right. So therefore your what you call, you need not find out this equation again, just a step, because just we are superimposing it here, because our interest is only this area on the negative side. So I hope you have understood this, right. So this is I have taken intentionally to make things that it is understandable to you, right. Ultimately if you make this one and integrate, you will get the same result. So why I will spend more time on this, directly I will do it. So that's why I have written like this, that minus 5 t by 4 into t dt, this is another straight line passing to the origin, that only slope is negative, right. So that means this RMS value, the average value will be, if you integrate this, it will become 0.625 volt, this will be the average value, right. Similarly RMS value also same thing, if you look into this RMS value also square root of this, so it is 1 upon t 0 to t v square dt. So this portion, first this portion 1 under root 1 upon t 0 to t by 4, and this 10 upon t by 4 square into this whole thing you make it square, right, plus 0 to 2 4, this whole thing you make it square, minus 5 by t by 4 square t square dt, right. So if you simplify, just do it, no? Otherwise my time will be saved. So it will become 3.23 volt, right. So this, that means this example intentionally I have taken for unsymmetrical waveform, from intuition you can make out that how to compute it, right. This is very easy, this is also unsymmetrical waveform, this is also unsymmetrical waveform. So while explaining this one, this triangular waveform, I should have gone here, I have overlooked, that is why initially I told thing, but everything is correct, right, same equation, everything is correct, right. So so this is your what you call, this is that example I took, such that you can understand this, right. So hope you have understood this. Only thing is that I hope this whatever things you can see it here, that is my class notes, right. So I have totally scanned it for you, just to see that things are okay or not, right. Anyway, so this is thing. Now next we will take another interesting example, and before going to this thing, we have taken this kind of example. Just see that how it is. For example, a simple series circuit is there, or resistance R is there, 2 ammeters are there, A1 and A2, 2 ammeters are there. A1 is called moving coil ammeter. Actually moving coil ammeter, it measures DC, right, DC current or DC voltage, here it is current ammeter, right. Moving coil instrument, it measures DC quantity. So here it is a moving coil ammeter, so it will measure DC, and A2 is the moving iron ammeter, this another ammeter A2 is there, it measures AC, right. Now in this case 2 sources are there, one your DC voltage source is connected, in series another is AC source, AC voltage source is connected, on switch is there, you close the switch, right. So this is the series circuit. It is given Vm is equal to 100 volt, that is the peak value is given 100 volt, and your what you call, and DC voltage V0 is given, this is 100 volt DC, this is 120 volt DC, right, and AC peak value Vm, these two are connected in series. Initially I have taken this kind of example, you will see this one example will make our your understanding very clear, right, and then A1 is the moving coil ammeter and A2 is the moving iron ammeter. So moving coil measures DC and moving iron measures AC, right, and the voltage acting in the circuit is, the total voltage will be 100 plus 100 sin omega t, because peak value is given 100 volt, right, and it is, that means Vt is equal to V0 plus Vm sin omega t. So V0 is your 120, so this is 120, right, and your Vm is equal to 100 volt, so 120 plus 100 sin omega t volt, right. So this is my your Vm. Now so the current IT will be your 6 plus 5 sin omega t, because this resistance R is given as 20 ohm, it is 20 ohm R is given, and this is my voltage 120 plus 100 sin omega t. So it is 120 plus 120 sin omega t divided by 20, that will be 6 plus 6 sin omega t, that is sorry, it is your what you call 100, so it is your 25, so 6 plus 5 sin omega t. So this is your IT is equal to 6 plus 5 sin omega t ampere, right. Now if you try to find out the average value it will 1 upon t 0 to t 6 plus 5 sin omega t dt, because this is IT into dt and omega is equal to 2 pi by t. Your this one you should keep it in mind, this you know it also from your higher secondary physics, omega is equal to 2 pi by t, right. So that is written here, right. By mistake initially it was t by 2 pi, actually it is not a 2 pi by 2 t, right. So then what you do, you just 0 to t 6 plus 5 sin omega t dt, and using this relationship omega is equal to 2 pi by t, right. You integrate this. If you integrate this, I am not showing it here, some time will be saved, then you just integrate it. I have this, I can do it integration for you, but it is a simple thing, from just simply integrate and use this relationship that omega is equal to 2 pi by t, right. So let me clear it. So you will use this relationship omega is equal to 2 pi by t and integrate it, you will get I average will be 6 ampere, that is your IDC, right. That means that your what you call average value will be just 6 ampere, because if you look into that 120 volt DC is there and your R is 20 ohm. So if you take 120 by 20, you will find it is 6 ampere, right, it will 6 ampere. So you are getting 6 ampere, so IDC will be 6 ampere. Then with this moving coil ammeter, the ammeter A1 will read 6 ampere, because your what you call moving coil ammeter is DC, right. So let me clear it. So similarly your RMS value, reading of ammeter, this is the reading of ammeter A1. Now for your just 1 minute. Now for the diagram will come later. Now RMS value, that is your reading of ammeter, your this will be whatever you will get, this portion is the reading of ammeter A1, this is your DC, this will read A1 will read your 6 ampere. Now come to RMS value. So in this case I is equal to square root of 1 upon t 0 to t 6 plus 5 sin omega t square, because I is equal to 6 plus 5 sin omega t square in dt. Now you just break it and just integrate it. If you integrate it, you will find that your and you will use this relationship. After integrating, you have to use this omega is equal to 2 pi by t. That means I am telling you, somewhere it will come in integration, you substitute omega t is equal to 2 pi, right. They you substitute, right. So after the substitution, you will find integration of sin omega t 0 to d, you will find this term will become 0, and this one also you make it your what you call that sin square omega t. So it will be 1 minus cos 2 omega t by 2, and then you integrate, right. So you will find that your this term only 2 from this integration whatever will come, it will be 25 by 2. The integration of this term will vanish, it will 0, and 36 will be there, because t will be cancelled, and under root 36 plus 2 5 by 2. So I am not doing it here, but please do it. It is very interesting, you please do it, but you will use omega is equal to 2 pi by t. So that is omega into capital T 2 pi. Similarly here also in this integration also you will put this one, omega t is equal to 2 pi, omega capital T is equal to 2 pi, right. So because when you will integrate this, this your what you call sin omega t, so it will be minus cos omega t upon omega, right, and there I put t is equal to capital T, and at the time you have to use this thing, and you will simplify. So you will get root over 36 plus 25 by 2. So that means whatever it will come, it will coming around your 7 ampere. So that will be the reading of ammeter A2, that is the moving iron ammeter. It will measure this RMS value. So that means moving iron ammeter, that is ammeter A2 will measure the RMS value, and this is your RMS value. So ultimately what we got? Ultimately the current value was 6 plus 5 sin omega t, right, that is your IT. So this is the fixed value, constant value, and this is the peak value. The peak value, that means it is the peak value, and we have seen that your peak factor your root 2, that means RMS value of the current will be actually 5 by root 2 ampere RMS value, right. So ultimately the effective value will be this 6, it is 6 square plus your 5 by root 2 square. So whatever you get now, 6 square 36, 5 by root 2 square is equally 25 by 2, right. So if you have this kind of thing, it's directly you can write its RMS value will be under root of 6 square plus whatever value is come, in this case 5 by root 2 square. So that is your what you call, this is what RMS value you are getting from this integration. So please do this integration of your own. I told you everything, right. So, please do this. Now, let me clear it. So, this is your ammeter, your what you call reading of the ammeter A2, which is 7 ampere approximately. So, next is your something is written that your moving iron, your something you should keep it in your mind, that moving coil instrument reads average value, moving iron, hot wire, electrodynamic and induction, your what you call type instruments read the RMS value of the signal, right. One thing is important to remember, when an AC supply of 220 volt is referred, it is meant the RMS value, right. The maximum value is 220 into root 2, so it is say 310 volt, right. So, in case of DC 220 volt, it is 220 volt only. If it is DC 220 means DC 220, if it is AC 220 means it is RMS value, you have to multiply by root 2 310 volt. That means that the shock level of AC for the same specified voltage is more than that of the DC voltage. That means in AC voltage you will get the peak value shock, and DC voltage you will get 220, I mean in DC voltage the shock will be 220 volt only. For AC supply 220 volt RMS means your shock level will be 310 volts. So, shock in AC will be more than the DC, right. So, this is something I have written for you, right. So, that means, and this is that your what you call, that is your that means this is the waveform, this is your Vt, Vt is equal to your what you call Vm sin omega t. This is the plot of your Vt, Vt is shown, right, and this is your what you call that your 100 sin omega t, right, 100 sin omega t, and this volt, this is your 120, this is 120 volt your DC, this 120 volt DC is made it, right, and this is your Vm is 100 sin omega t. If you add these two, then this will be your what you call this Vt, right. That means this one, your this plot, this is 120 plus 100 sin omega t, this plot is this one, and individually if you make it, this is 100 sin omega t, and this is the DC means is a constant line, this is 120 volt is mentioned. So, this is the resultant of this. Thank you very much, we will be back again.